So I'm David Santo, and as you guys know, I'm part of the BD2K Links DCAC program, and I'm here to talk about my age prediction project. So the inspiration for this project came from a paper written 2 years ago by the Mayan Lab, which could determine someone's age based on 1,573 parameters from 380,000 patients in Mount Sinai's electronic medical record system. And this deep learning model could predict someone's age within 7 years. So my job was to miniaturize it and deploy it for consumer use. So the first thing I did was I recreated the model described in the paper, and I just tried to get a feel for the deep learning framework that it was using. So why do we care about physiological age? So the predicted age is the physiological age of a person. So in the paper, among other things, described two groups of people, one of which had a much higher physiological age than their chronological age, and one had a much lower physiological age than their chronological age. And the first group seemed to have a lot of health risks. They seemed to have higher measurements such as higher blood pressure, higher cholesterol, and more damaged liver, among other things. And the second group seemed to have a much better regulated system, and because of that they had health benefits. So more importantly, it just seems to be a good metric for health overall. So the only thing is that it's not viable for someone to put in 1,573 things about themselves into any sort of form, because why would they know that or have the time to put that in, even if they did? So I wanted to miniaturize it in some way. So my job was to figure out how many variables I would have to ask the person and still get an accurate reading. And there's a big trade-off between convenience and accuracy, as shown. So what I did is that I took the 100 most popular parameters in the electronic medical records, so stuff like blood pressure, hematocrit levels, phosphorus in your blood, anything. And I took the top 10 variables, I put that into the deep learning model, and then I ran the results and saw how accurate it was. So for the top 10 variables, it was able to predict age within 12 years on average. Then I took the top 20, and it predicted age on average within 9.6 years. Then it did 30, 40, 50, so on until 100. So I decided to go with 20 variables for the final amount for how much I want people to put in, because it's kind of the sweet spot between accuracy and convenience, and any more after 20 people probably wouldn't know their values, or they wouldn't want to put that many in. So also I would be improving that baseline number in the coming weeks. So this is kind of the pathway I did in order to improve that initial 9.6 years on average. So the first thing I did is that I threw all the variables into a multivariate regression analysis to find some sort of linear relationship between all selected variables and age. And I took the top 20 with the highest R squared, and that turned out to be pretty well. So when pretty good. So when I put that into the deep learning model, it was able to predict age on average within 9.2 years. So then I used another algorithm called mutual information, which can also determine quadratic, cubic, or other types of relationships between any two variables. And that didn't turn out as well. I was able to predict age on average within 9.7 years. So I decided to go with the results from the multivariate regression test. So after that, I performed something called a robustness test in order to ensure that each variable was significantly contributing to the age calculation. So here's an example of a robustness test. What I would do is that from all the 20 variables, I would remove one, and then I would run the deep learning model on the other 19, find out how accurate it was, and then subtract the accuracy from the original 20. So for instance, when I removed systolic blood pressure from the model, on average, the model predicted 0.67 years worse than when all 20 variables were there. So that would be a significant variable. But if I took out something like mean platelet volume over there, the model actually performed better. So I could replace that variable with something else that would be more telling for age. And I did that again and again and again until I was satisfied with how all the variables were. So this is the final list of the variables that I chose. And my next step was to create some sort of interface to have people put in their values and hopefully get some results from there. So over the next couple of weeks, I developed an app, which we've now called PALM2A, standing for Physical and Laboratory Measurements to Age. And it's a web and mobile app that's going to be on the App Store really soon. So future work will include some sort of check to make sure that any values aren't too high or too low, and if any values that you input are, it could alert you that, hey, your cholesterol is maybe too high, maybe you should go take a look at it somewhere. And also the cool thing that if we're with the electronic medical records, there's a lot of potential for future deep learning or machine learning models that can predict if any patient is at risk for diabetes or cystic fibrosis or any other condition. And lastly, because all the information is already in Mount Sinai's portal, it could easily integrate it with just a click of a button and put in all their values and calculate some age. So I just want to thank my direct supervisor, Zichen, and my PI, Avi, for their incredible mentorship. I would not have been able to do any of this otherwise. Also thank you to Sherry for organizing this wonderful program and to the rest of the lab for their unending support. Any questions?